Okay guys, here we go. Lesson 13, momentum. Apologies on the previous video. I had it plugged into the mains and the AC electricity was causing that buzzing noise. So apologies for that, it really was annoying. Momentum. Let's imagine you're stood at the bottom of a hill and somebody has a little pushchair and the pushchair gets loose. And you're going to be the hero of the day, little baby in the pushchair. And the pushchair's heading down. And you're going to catch it. I'd fancy your odds. The pushchair comes down. I think you'd probably manage it. But then imagine we rewind that. And instead of it being a pushchair, it's a lorry. A great big one. This time you try and stop it. And, good on you for giving it a go, but I think you're pretty much going to be splattered. And that's all because of momentum. Momentum is a quantity that means objects want to remain in motion once they start moving. So momentum is a quantity a moving body has that wants it to keep moving. So getting in front of something big and heavy really wants to keep moving, as opposed to something small means the momentum has changed. Now the equation is really easy. The momentum of an object is equal to the mass of the object, and I'll put the units in a minute, times the velocity of the object. Now the unit is a funny one. Kilograms for mass, meters per second for velocity. So the unit is made of those two. It is kilograms meters per second, like so. So that's the equation. So if anything, if you're falling asleep in my videos, remember that. So that's the first bit. Now we can whack it in a triangle as usual. Hopefully that's nice and easy for you. The symbol for momentum is usually capital P. People get, triangle. People get really confused though. It will draw, it will. Yes, first go. People get confused because P usually is power. So I like to write MMT, momentum, is mass times velocity. And if we use that, we can rearrange it to find momentum is over velocity, or velocity is momentum over the mass. So that's the triangle. I'll put some questions up to have a little go on that. The bit I really want to get to, though, is this law called the conservation of momentum. The universe has got a couple of really basic rules that it has to stick to. One of them is you can't make mass, and you learn that quite early on in chemistry. Another one is you can't make energy and destroy it, the conservation of energy. And the other one is conservation of momentum. When things are moving, it always has to be the same amount of momentum in the system afterwards as it was before. So I'll give you a couple of examples where you've seen this before. If you shoot a gun, shoot the bullet that way, you get ricochet coming backwards off, particularly if you've ever shot a shotgun. They tell you to put it right into your shoulder and brace yourself because you're going to get pushed backwards. Same with rockets. Fire a rocket upwards, so you push the propellant downwards, you get pushed upwards. It's a kind of a link to Newton's third law. If you remember Newton's third law, for every action there is a reaction. This is it in action. So that's the idea. A good way to test it for yourself is stand on a skateboard and get a basketball, big basketball, throw it as hard as you can that way, and the skateboard will go that way. So you can see it in action. So that's conservation of momentum. I'm going to write it down as it should be. Conservation of, I'm going to write MMT, momentum states, I'm going to put it in blue and red, the momentum before a collision, that's an S, is the same as, I'm going to put this one in red, I'm going to colour code from now on, as the momentum after. So let's give it a go. What I like to do is I like to draw a box with stuff in it and call it before. So if I draw this box here, come on, it's a square. Let's go. Okay, so I'm going to draw my momentum at the beginning here. Let's get rid of that. I'm going to draw two cars, do them in blue as well. So there's the path, there's the road. Got my little trailer here, and it weighs 2 kilograms, and it's moving along at, let's keep the numbers dead easy, 2 meters per second. And it's going to crash into a bigger one. I know why this doesn't work now. You have to finish at the very point you started. There you go. It's going to crash into a bigger one, which is 4 kilograms. And at the moment, its velocity is 0. It's not moving. So let's have a look at, we want the total momentum. So this is before. Blue is always before. So let's have a look. We've got this one. Let's call it M, the mass, number 1. Let's call this velocity number 1, 2 meters per second. Let's call this mass number 2 and velocity number 2. So we can work them out. Let's find the momentum of the first one. Let's call it 1. So we've got M1 times V1 equals 2 times 2 equals 4 kilograms meters per second. But I want all of it. So I'm going to add it to M2 V2, which is 4 times 0. Okay, so total momentum is 4, add 0, which is 4 kilograms meters per second. With me so far. So that is the momentum of the system. Remember, a system is just all the energy, matter, momentum inside a space where you're calculating something out. Now, let's take that system. There's a collision, so I'm going to copy it. I'm going to paste it. But now I'm going to make some changes. Red, after. So after the collision. And what's happened? Well, we're going to imagine that the car, we're going to wipe out these. We're going to put them out the way for a minute up here. We're going to imagine the car, bang, went and hit the one over here. So let's try that again. We'll move that over there. Bang, it's hit it. This one now is going to move away with a velocity because the momentum has to be conserved. So it's no longer going to be 0. I can move my values back over here. So let's have a look at what they are. Well, it's not going to change. So that's going to be 2 kilograms. The velocity is going to be 0 meters per second because it's stopped. It's hit number 2, this car. And this car is going to move away. And we're going to find out how fast it's going to go. So let's have a look at the momentum this time. So we're going to take this out. We're going to take this out. But we're going to leave that there. Because conservation of momentum means that, and I'm going to put this in green, this number here has to be the same as that number there. the conservation of momentum. Okay, 3 M's. I got a bit carried away. So let's have a look. How does this shake out? M1V1, that's easy. 2 kilograms times 0 meters per second. It's not moving, so that's 0. Add M2 times V2. Now we can figure this out. 4 times the velocity. We don't know it, but what we do know is that that's 0. That's going to be plus something equals 4. So this has got to be 1 meter per second. Because 4, let me get rid of that. 4 times 1 equals 4. This was 0, so you don't need it. You can get rid of it. So that's how we can find the missing velocity in a system. Now, where I've seen this come up in an exam is a boat. Somebody on a boat stood there like that, and the person's going to jump. And they say, describe what happens to the boat when the person jumps this way. And it was, I think, a 3 or 4 marker question, and the boat moves that way. And the question is why? And the answer is conservation of momentum. When they were together, boop, and they're not moving, the total momentum was 0. The person's not moving, the boat wasn't moving, so 0. Whoops. When the person jumps forward, though, this person now has a momentum going this way, momentum, and to make it all add up to 0, the boat must have equal and opposite momentum. Let's call it negative momentum. Do you remember we talked about vectors having plus and minus numbers? Here's vectors in action. Where did the vector come from? Well, mass times velocity. Do you remember velocity is a vector? So that means momentum is a vector. So there it is in action. This is why you need to learn vectors. Okay, so if I took the momentum of this one and I added it to that one, I get 0 afterwards. And it's why the gun ricochets and pushes you backwards. It's why you will move on your skateboard. At the moment, total is 0. If you throw the ball, off it goes, then it'll have momentum this way, MMT. But to make it equal to 0, you will have negative momentum. So you'll go in the opposite direction, all to conserve momentum. And if you've kept up with me so far, well done. It's a bit tricky, but it's not impossible. Have a practice. Take care. Bye-bye.